Alright, I hope you, well, for one, I expect you to behave for the sub, but I know you will. So this is easier than us just losing a whole day of algebra, and I know you're excited to watch a video and hear me, even though I'm not there. So you're welcome for that. So the goal is, when we're done with all this, to be able to factor perfect square trinomials and the difference of two squares. So just like we did special cases, we were multiplying, now we're doing special cases while we're factoring. So you should have out your note packet. You can do this individually. And I do want you to listen to the sound, not just watch the writing and copy it. And you should fill out your note packet on day 3 as we go. So if we review, we remember when we did special cases together in, we're multiplying, if it was a plus b squared, we took a plus b times a plus b, and we distributed, and that came up with the fancy rule of the first term squared plus 2 times a times b, the two terms, and then the second term squared. So, and then the same thing, the difference of 2 minus a minus b, you just, it's the negative in the middle instead of the, I don't think I'm even recording. Am I recording or not? Oh, yeah, I am. Whoopsie. So let's see if I can, because I think I'm echoing. Okay, hopefully not. Alright, hopefully it's on. Alright, so any trinomial in the form of a squared plus 2ab plus b squared, that just means the first term squared, the last term squared, and then in between is the two terms multiplied together times 2. So if it ever looks like that, it is a perfect square trinomial. I guess I could spell perfect, right? You could just put perfect square. It's a perfect square trinomial. So like this first example, x squared, 8x, 16. Same thing with the x method. We put 16 in the bottom and 8 in the top. And we're going to wind up with 4 times 4, because 4 times 4 is 16, and 4 plus 4 is 8. So then we put it in the same form that we would have like we have been factoring already. I think we will have gone over this on Monday. I'm recording this before Monday though. When you've got the number out front of your first variable, not just when there's a number there, it's not just an invisible one. You have to multiply the first number by the last number, and that's the number that goes in the bottom. So we've got to multiply to get 36, add to get negative 12, and they found negative 6 and negative 6. And then, again, we'll have talked about this, but you have to take each term and divide it by the initial number up front, so 4. And then negative 6 over 4 reduces to negative 3 over 2. Then when you're writing your factors, the bottom number goes in front of the x, and the second number is what's subtracted or added if it was positive. So how do we recognize these perfect square terms? If the first and the last term are perfect squares, it's possible that it's a perfect square trinomial. If the middle term is, oopsie, well, that's actually better, isn't it? The middle term is twice the product of a factor from the first term and a factor from the last term. So like if the middle number, 12 in this example, the 2 times 2 is 4, 3 times 3 is 9, the first and last terms, and 2 times 3 doubled is the middle term. That didn't make a lot of sense, but it's just the square root of the first term, square root of the last term, times 2. If doing that math equals the middle number, then it is a perfect square trinomial. Alright, so the first example is just another one where they did the same thing we did above. There's no number out front, so if we were going to do the x method, they have put 36 in the bottom, negative 12 in the top, and the two numbers to multiply together, negative 6 and negative 6. So they wind up with x minus 6 and x minus 6. And you don't have to write them out both. That's why we call them perfect squares. So you can write like they did here, x minus 6 squared. Alright, so let's try two of them. If you'd like to pause it here and try them by yourself, great. If not, I'm going to go ahead and go over them. So x method, 9 and 6. We know it's going to be a perfect square because this is the perfect square section. So 3 times 3 is 9, and 3 plus 3 is also 6. So we've got x plus 3, which can be written as x plus 3 squared. Alright, then the next one, 49 on the bottom, negative 14 on the top. Remember to keep the signs. And since it's a negative 14, we know that it might have to be negative 7 and negative 7, because that is going to equal 49, but add together to get negative 14. So we'll have x minus 7 and x minus 7, which can be written as x minus 7 squared. Alright, this next one below here is just a word problem that kind of gives you an application. Digital images are composed of thousands of tiny pixels rendered as squares. We're doing the area. This is the area. And we want to know what's the length of one side. So they're just going to take this and they're going to do the same method we did in the example on the last page and wind up with that as one side. Alright, so let's do one of our own. You're building a square patio. The area of the patio is 16m squared minus 72m plus 81. And remember, when there's a number out front, we have to multiply. Definitely going to have to use my calculator, because we're going to multiply these two. 16 times 81. So that'll go on the bottom, which is a big old number, 1296. The 9, not a 4. 9, 6, and then negative 72 in the top. Since we're in the perfect square section, you know you should be able to take the square root of the bottom number, which is going to be 36 times 36 is going to give us 1296. And they both need to be negative for us to add together and get negative 72. So write it in the form. Oh, I forgot. And remember, when it's got a number out front, you have to take your terms and divide them by 16, or the first term, which is 16, and reduce. Negative 36 over 16 reduces to, let's see, that would be 2, 4, 9, negative 9 over 4. And when you write it out, the bottom number goes in front of the x, and the other number goes next. So 4x minus 9, and it's squared because it'd be times itself. Alright, shift to the page. Now we'll go to the difference of two squares. That's just when you've got the first term is squared and a minus in between, and the second term is also squared. So there's some examples above. This is the easiest because all you have to do is put the square root of the first one plus the square root of the second one, and then the same thing but minus instead of plus. So, where it says example 3, z times z, we can check it by FOILing it out. Z times z is z squared. 3 times negative 3 is negative 9. 3 times z is 3z. No, what did I do wrong? No, back. That was z times 3, my bad. 3z, negative 3z, and then minus 9. These cancel out, negative 3 plus 3. So yes, I'm left with what I started with, z squared minus 9. So this one's got an easy trick with it. So this one, you can pause it if you want to do it on your own. The square root of v squared is just v. The square root of 100 is 10. So we have v plus 10 and v minus 10. That's all. Same with this second one. The square root of s squared is s. And 15 is not a perfect square. So this one, it doesn't work. You can't do it that way because 15 is not a perfect square. So let's see, what if it were 25? Oops, don't need that. Oh, sorry. So you got an s, and the square root of s squared is s squared, or the square root of 25 is 5. So s plus 5 and s minus 5. Must have been a typo or a misprint when I wrote it. All right, look at number 4, example 4. This time there's a number out front, but still you're just taking the square root of the front term and the square root of the second term. You just happen to also have to take the square root of the number and of the x. So square root of 16 is 4, square root of x squared is x. And it's really not any more complicated. So square root, you can pause this if you want to do it by yourself. Square root of 25 is 5. Square root of d is d. D squared is d. Square root of 64 is 8, so a plus 8. And then on this side, we'll do the same thing, but minus 8. So I hope this is fairly easy for you. Okay, last page for today, I'm pretty sure. And these notes aren't really as long as you feel like. It's just because they're in my handwriting and I wrote big. So if you ever have to factor out a common factor first, sometimes we have to do that in order for it to factor correctly. If there's a number that'll go into both numbers within your quadratic equation, you need to pull out the common factor. So between 24 and 6, 6 is a common factor. So they pull out a 6, leave inside what you're left with, just like we've done before when we've been factoring. Then you can take the square root of both and write it like we have been on the previous examples. So like on this first you try one, a number that will go into 12 and 48. Well, 12 will go into both of them, so I can pull out 12. 12 times 1 is 12, so I don't even need a number out front. And then x squared, t, this one's a t. And then 12 times negative 4 is 48. So I've pulled out my greatest common factor. Now I can write it as the product of two binomials. Square root of t squared is t. Square root of 4 is 2. So a plus 2 and a minus 2. Make sure you don't forget to leave the number that you factored out front. All right, this one has 3 parts, but 3 will go into all of them. So pull out a 3. Then we'll have 4x squared plus 4x plus 1. And that's the most you can do on that one. Well, no, it's like the first one. Oops. So in the bottom of the square, you take the front and the last number, multiply them. Then the middle number in the top. 2 and 2 are the perfect, are the things that will multiply to get 4 and add to get 4 in this case. And remember, you have to divide it by the number that was up front. We've done this a couple times. And remember, the bottom number goes in front of the x. The top number, well, you have to reduce it first. I'm sorry, I'm getting lost. You have to reduce it first, same as 1/2. Bottom number goes in front of the x. Top number is what's added or subtracted. So we'll have 3 in front. Can't forget that because that's what we factored out. And then 2x plus 1 and 2x plus 1 because since both sides of this were positive. And that can be written as 3, 2x plus 1 squared. Alright, that one was a little complicated. If you don't get that one, I get it, and I can re-explain it sometime. Alright, the lesson check. I do want you to pause and try this on your own, but then you can replay and check it. I'm going to go over them. But I encourage you, and I'm requiring you to do them on your own. And I'll leave that in my sub-plans. So this one, 64 on the bottom, negative 16 on the top. Multiply to get 64. Well, this is a perfect square, so I can do 8 and 8. And for it to get negative 16 when I add, they'll both have to be negative. So I can have, this is a y minus 8 and y minus 8, which can be written as y minus 8 squared. Okay, the next one, remember to multiply. So 9 times 4 is 36. 12 in the top. 6 times 6 is 36, and 6 plus 6 is 12. Never forget to divide by the first number, and then reduce. 2/3 if you divide both by 3. The top number goes in front of the x, and the bottom number goes in front of the x. The top number is what's added. 3x squared, 3x plus 2, 3x plus 2, which can be written as 3x plus 2 squared. Alright, this is one of the easy ones that you should like. The square root of p squared is p. Square root of 36 is 6. So a plus 6 and a minus 6. Last one, the area of a square is that. What's the side length of the square? So first, see if there's something you can factor out of all of them. 36, 65, no, there's not. Alright, so let's use the x. Multiply the front number and the last number first. 36 times 25, 900, and then 60 in the top. And then find something that'll multiply together to get 900 and add to get 60. That'll be 30. Remember to divide by your front number and then reduce. So this would be, if we divide by 3, it's 10 over 12. And then that'll reduce to 5 over 6. So top number or bottom number is in front of the x, and the other number is what's added, and we know that it's squared, but one side is 6x plus 5 long. Alright, so now she's going to have some assignments for you. She'll give them to you. Just tell her you're done. And these notes should be filled out, and then whatever she assigns you, I expect to be finished. And she's also going to give you some homework, and that'll be due on Friday. So I'll see you when I get back.